On September 15, 2017, a spacecraft the size of a school bus plunged into Saturn at 77,000 miles per hour, transmitting data until the very second it vaporized. In its final moments, Cassini tasted Saturn's atmosphere for the first and last time, sending secrets that arrived at Earth 83 minutes later, long after the messenger was dead. This deliberate suicide ended the most successful planetary mission in history, a 20-year odyssey that discovered ocean worlds, methane rain, and the ingredients for life where nobody expected them. This is the story of Cassini. The probe that revealed Saturn's moons might be the best places to find alien life in our solar system. Cassini almost never happened. It was too expensive, too complex, too international. NASA, the European Space Agency, and the Italian Space Agency had to work together. 17 countries, thousands of scientists, 3 different measurement systems. The Americans built the orbiter. The Europeans built the Titan probe. The Italians built the communication system. One mistake by any team would doom everyone. The spacecraft took 7 years to build and cost $3.3 billion, about the price of 3 Hollywood blockbusters today. It weighed 5,112 kilograms fully fueled, making it one of the heaviest planetary probes ever launched. Too heavy for any rocket to send directly to Saturn, Cassini would need to steal energy from planets, performing a gravitational ballet across the solar system. But the real controversy was power. Cassini carried 72 pounds of plutonium-238, the most ever launched. Protesters tried to stop the launch, fearing a Challenger-style explosion would rain radioactive material across Florida. NASA calculated the odds of plutonium release at 1 in 345. Those were uncomfortable odds when failure meant contaminating an entire state. October 15, 1997, 4:43 a.m., Cassini launches aboard a Titan IVB rocket, the most powerful unmanned rocket in America's arsenal. The launch is flawless, but Cassini isn't heading to Saturn. It's heading to Venus. Twice. The 7-year journey to Saturn would cover 2.2 billion miles, swing by Venus twice, Earth once, and Jupiter once, building up speed like a cosmic slingshot. August 18, 1999. Cassini approaches Earth at 42,000 miles per hour, about to perform the riskiest maneuver of its mission, a flyby just 727 miles above the Pacific Ocean. If calculations are wrong by a fraction of a degree, Cassini crashes into Earth with 72 pounds of plutonium. NASA doesn't publicize the exact time, fearing protests or worse. The flyby is perfect, boosting Cassini's speed by 11,000 miles per hour. But as it passes Earth, Cassini's cameras turn back and photograph our planet, a pale blue dot from 600,000 miles away. Carl Sagan had died 2 years earlier, never seeing his dream mission launch. This photo was Cassini's tribute, Earth as Sagan described it, a mote of dust suspended in a sunbeam. During the Jupiter flyby in December 2000, Cassini doesn't just steal energy, it conducts science. Working with Galileo, still orbiting Jupiter, they create the first dual spacecraft observation of the giant planet. Cassini discovers strange interactions between Jupiter's magnetosphere and solar wind, invisible to single spacecraft. It's practicing for Saturn, July 1, 2004. After 7 years and 2.2 billion miles, Cassini arrives at Saturn. But arrival means threading a needle, passing through a gap in Saturn's rings just 15,000 miles wide while traveling at 54,000 miles per hour. One ring particle could destroy the spacecraft. Cassini turns its high-gain antenna forward as a shield and fires its engine for 96 minutes, the longest burn of its mission. The burn is perfect. Cassini is captured by Saturn's gravity, becoming the first spacecraft to orbit the ringed planet. The images it sends back are breathtaking. Saturn's rings in detail never seen before, composed of billions of particles from house-sized boulders to microscopic ice crystals, all orbiting in a paper-thin disk that could fit between Earth and the Moon. But the rings are alive. Cassini discovers propeller-shaped gaps created by tiny moonlets, spokes that rotate with the rings, possibly electrostatically levitated dust. Vertical structures at ring edges towering 1.5 miles high, casting shadows that reveal the rings aren't perfectly flat. Saturn's rings aren't static. They're a dynamic system, constantly changing. December 25, 2004. Cassini releases the Huygens probe toward Titan, Saturn's largest moon. For 20 days, Huygens coasts through space, aimed at a world hidden beneath orange smog. On January 14, 2005, Huygens slams into Titan's atmosphere at 13,000 miles per hour. For the next 2.5 hours, it will fall through an alien sky, photographing its own descent into the unknown. Titan's atmosphere is thicker than Earth's, the pressure like being 15 feet underwater. As Huygens descends, it discovers a world both alien and familiar. Rivers carved into the landscape, but flowing with liquid methane, lakes and seas of hydrocarbons, rain that would explode on Earth. The surface temperature, minus 290 degrees Fahrenheit. At 7 miles altitude, Huygens emerges below the haze and sees Titan's surface clearly. Dark drainage channels, bright highlands, a shoreline. But is it approaching land or sea? The probe is designed for either, but nobody knows. At 10 feet per second, Huygens impacts and bounces. It's landed on damp sand, the consistency of wet clay, saturated with methane. For 72 minutes, Huygens transmits from Titan's surface, the most distant landing ever achieved. The photos show rounded pebbles of water ice, eroded by methane rain. The probe's heat vaporizes methane from the soil, creating a brief methane fog around it. Huygens hears Titan, recording sounds of alien wind. Then its batteries die, and humanity's first probe on Titan falls silent forever. February 2005. Cassini flies by Enceladus, a small moon everyone expected to be dead. Instead, Cassini's magnetometer goes crazy. Something is deflecting Saturn's magnetic field around Enceladus. Then Cassini sees them, geysers erupting from the South Pole, shooting water hundreds of miles into space. This tiny frozen moon is alive. Cassini makes 23 flybys of Enceladus, some just 16 miles above the surface, so close it flies through the geysers. Its instruments taste the spray, water, organic compounds, and salt. This isn't just steam, it's ocean water from beneath the ice. Enceladus has a global ocean, kept liquid by tidal heating, and it's spraying that ocean into space. The implications stagger scientists. The geysers contain complex organic molecules, the building blocks of life. The ocean is alkaline, like Earth's oceans. There's evidence of hydrothermal vents on the ocean floor, exactly where life might have started on Earth. Enceladus isn't just habitable, it's advertising its habitability, literally ejecting its ocean into space for us to sample. Cassini discovers that Enceladus feeds Saturn's E-ring, the largest ring, constantly replenishing it with ice particles. This tiny moon, just 300 miles wide, creates a ring that stretches 600,000 miles. Enceladus is a cosmic snow machine, and Cassini flies through its blizzard, tasting an alien ocean without having to drill through ice. Over 127 flybys, Cassini unveils Titan as Earth's twisted twin. It has lakes, seas, rivers, rain, seasons, but all with hydrocarbons instead of water. Kraken Mare, Titan's largest sea, is bigger than all North America's Great Lakes combined, filled with liquid methane and ethane deep enough to submerge skyscrapers. Cassini's radar pierces Titan's haze, revealing a landscape shaped by methane. Flash floods carve canyons. Rivers meander to seas. Islands dot the lakes. Some lakes are so still and smooth, they create perfect mirror reflections of Saturn. Others have waves, alien surf on hydrocarbon seas. It's the only place besides Earth with stable surface liquids. But Titan gets weirder. Cassini detects massive dunes near the equator, not sand, but grains of frozen hydrocarbons blown by winds into dunes 300 feet high. These hydrocarbon particles fall like snow from Titan's atmosphere, accumulate, then get sculpted by wind. Titan literally snows gasoline. The atmosphere itself is a chemical factory. Sunlight and Saturn's magnetosphere break apart methane and nitrogen, creating complex organics that drift down as orange smog. Cassini detects over 50 complex molecules, including amino acids precursors. Titan is running the experiment that created life on Earth, just at -290 degrees, with hydrocarbons instead of water. Cassini witnesses Saturn's weather on steroids. In 2010, a storm erupts that eventually wraps around the entire planet, a thunderstorm the size of Earth that lasts 200 days. Lightning bolts 10,000 times more powerful than Earth's. The storm is so violent it disrupts Saturn's radio emissions, screaming static across the solar system. The hexagon at Saturn's north pole defies explanation. A six-sided jet stream, each side longer than Earth's diameter, rotating once every 10.5 hours. Inside, a hurricane with an eye 1,250 miles wide, 50 times larger than typical Earth hurricanes. The hexagon is stable, unchanged since Voyager saw it in 1981. Nobody fully understands why Saturn creates a hexagonal storm. At the South Pole, a different monster. A hurricane with an eye wall 60 miles high, wind speeds of 350 miles per hour. It's locked to the pole, unable to drift like Earth hurricanes. Cassini flies directly over it, looking down into the eye, seeing cloud structures impossible on Earth. By 2017, Cassini is running out of fuel. Like Galileo before it, Cassini must die to protect the moons it discovered. If it crashes on Enceladus or Titan, Earth microbes could contaminate potentially habitable worlds. NASA chooses spectacular suicide over mundane drift. The grand finale, 22 orbits between Saturn and its innermost rings, a gap just 1,200 miles wide. No spacecraft has ever attempted this. Ring particles could destroy Cassini, but it's going to die anyway. Might as well die learning. Each orbit takes 6 days, diving through the gap at 76,000 miles per hour. Cassini discovers rain, ring particles falling onto Saturn, 10,000 kilograms per second, enough to fill an Olympic pool in half an hour. It measures Saturn's internal rotation precisely, 10 hours, 33 minutes, 38 seconds. It detects organic compounds in Saturn's upper atmosphere, materials that shouldn't exist there. September 15th, 2017, 3:31 a.m. Pacific Time. Cassini makes its final plunge. It fights to stay oriented, transmitting data as atmospheric drag tears it apart. Temperature rises. Thrusters fire at 100%, trying to maintain antenna lock with Earth. At 3:31:48, the signal fluctuates. At 3:32, silence. Cassini is gone, vaporized, its atoms now part of Saturn forever.